Hi there, everybody. Welcome to Mondays with Mike. It is an interesting Monday with beautiful weather here locally and some not so fantastic weather brewing in the tropics. So we're going to talk about the forecast short term and also talk about a few things involving the system that is likely to be a tropical storm, hurricane. Depending on when you watch this, it may actually have already been upgraded. And I want to talk, most of what I wanted to talk about here is a couple of things involving the cone of uncertainty and the concept of the cone of uncertainty versus the cone of influence, or the cone of uncertainty versus the area of influence, because they really are two very, very different things, especially as you get closer to landfall and the cone gets smaller and sometimes the storm gets bigger. So I wanted to start out with the good news, which is that I hope you were able to enjoy the weekend. The weather obviously was outstanding with a front moving in late in the day Friday and early Saturday. It helped the winds to switch back around to the north, and we actually got some drier air coming in. High temperatures in the upper 80s and low humidity in place. We got down to 70 degrees for a low, both at Bush Airport on Saturday morning and Sunday morning. This morning, Monday morning, we did get down into the 60s in Houston, and it was the first time since the 31st day of May. So more than 3 months ago. That was the last time we were as cool as we were this morning. And there were some spots that got down into the 50s this morning, which is amazing. I think Huntsville was in the 50s. We also got down to the 50s around the Brenham area. I mean, look, you can't beat that. And even spots like Conroe and the Woodlands and Hempstead, and you guys were down to about 62 or so this morning. So that's pretty spectacular considering it is still summertime technically, although we are in what we call meteorological fall, which is September, October, November. We are at the heart of hurricane season. The historical peak of hurricane season is September the 10th, and just general the second week of September. And so you would expect that things are going to get busier, and they are. We actually have a couple of systems out in the Atlantic that are brewing, and then we have obviously the one that we're going to be talking about in the Gulf of Mexico that is brewing. So I do have my my monitor behind me that I'm going to be referring to here to show you a couple things. I think I'm going to pull the camera closer a little bit from time to time. But in general, let me just give you an update as to what we're looking at and some of the possible impacts from this developing tropical system that we have. So let me go ahead and just move this a little bit closer. So as of midday today, Monday, this thing has really been growing in size. And that's an indication that the pressure is going to be dropping. And keep in mind, too, that the water temperature out there in the Gulf of Mexico is really like a bathtub. It's between about 86 and up to 89 degrees, what we call the SST, or the sea surface temperature. The way tropical systems are fueled is that the energy basically from the ocean, in this case from the Gulf of Mexico, gets transferred into the clouds. It's one of the overall features of the atmospheric circulation, or what you would call like the thermodynamics of the atmosphere, is that tropical systems transform the heat from the tropics, the tropical oceans, farther to the north. And so that's why hurricanes, generally travel to the north. And so it distributes that energy, moves that heat farther to the north. So that's what's in the process of happening out there right now, is that you're getting all of these big storms forming from the generally pretty hot water out there in the Gulf of Mexico. And it's likely that we're going to see the system get stronger as we progress through the day today. I wanted to share with you, so we have several models at our disposal. Most of them are government models. Like, for example, the GFS model that's NOAA's model. And that's our primary American computer model that we use for like short to medium term forecasting. So, maybe the first 2 or 3 days, and then it still stays pretty accurate when you get to like day 3 through day 7 or 8, still pretty good. And it goes all the way out to 16 days. And obviously that far out, it's not going to be able to have pinpoint accuracy for where a storm is going to be, but it still can show you trends and some basics. In this case, the GFS model, which I'll show you here in a minute, is looking a little bit better for Houston and a little bit worse for Louisiana, and then the same thing with the Euro model. But these things can change, and sometimes there's one model that can pick up on changes before the others do. And I'm not saying that's 100% the case here, but I wanted to share with you the Fox model, which is our exclusive model within the station group, not within Fox 26, but within Fox television stations and Fox Weather. This is based on a model called the WRF, which is the Weather Research and Forecasting Model. And for those of you, and I'm not a computer scientist by any stretch, but this is what's called an open source model. And it just means that anybody can work with it. So for people who are real computer nerdy, not necessarily like me, but people who really know what they're doing, you can download the model into your computer. I think you have to have probably a really fast computer, but you could download the model in and you can make modifications to it. So it's used heavily at colleges and universities where people are doing research, which is why it's called the Weather Research and Forecasting Model. So like my friend Patrick, he's still with the National Weather Service, and when he got his master's degree from U of H, I believe, if he's watching right now, you can correct me, Pat, but he used the Weather Research and Forecasting Model to experiment with predicting flooding in Houston or excessive rainfall events in Houston. So you can modify it, its like resolution, and make it real city specific or state specific. In this case, Fox, a meteorologist in Tampa, Jim Weber, started changing the WRF model to focus on Central Florida pop-up storms and sea breeze storms. And the reason he did that is because they were forecasting for Tampa and for Orlando and that general area. Now it's been expanded through the years to cover all of the United States, and also they have a tropical model that covers all of the tropics. I've switched just to the United States or continental US view because we're closer to this thing's landfall, which is expected to be on Wednesday, and it's a higher resolution view. So I know that was a lot of talking. I probably could have made that a lot simpler, but let me show you this. So let me put this into motion here. And so this is 11 p.m. Tuesday, 11 p.m. tomorrow, with the center of circulation pretty clearly shown there, well to the south of Galveston. And then I pause it here and I've put a measurement on there. I used our little ruler tool that we have here, and I hope you can see that. It's about 55 miles is, according to this model, about 55 miles away is where the the western part of the eye wall might be, about 55 miles away from Galveston. Now, if it were, then you would probably get some pretty consistent tropical storm force winds for the Bolivar Peninsula, for Galveston Island, maybe even Texas City, maybe even Clear Lake. I mean, we can't rule that out. 40, 50 mile an hour winds. Other models that we have are not showing the center of circulation coming as close to us, but I wanted to show this to you to just so that nobody sort of gets lulled into a sense of complacency, because when you see the cone of uncertainty as of this morning, it does kind of make it look like, it's curving, it's moving away from us, but that's not always how these things work. So anyway, that's the Fox model. This spaghetti plot here is going to show a combination of models. Most of these are based on the GFS, which is that American model, and also what we call consensus models that are assembled from the National Hurricane Center. It's kind of neat the way they do it, because they'll take like 2/3 of this model and 1/3 of another model, or they might do 50-50, two different models, to use the influence of one model and kind of take the average with the others, which I think is a great way to do it. So anyway, here we are, Houston, Galveston, and those lines are all pretty far to our east, enough that we're probably not going to have huge impacts given this latest set of of models, which doesn't mean it's necessarily going to stay that way. So when we look at the GFS model, which is our American model, and it's showing here a movement that you'll notice is going to be not as close here to Houston and Galveston. So we pause it here 11 a.m. Wednesday, and this center, let me go ahead and pull up, I want to do that, that tool that I just showed you. That measurement tool I want to show you here real quick. Let's see, we'll look ahead at here. And let's see, this one is about 88 miles. About 88 miles away. So remember, the Fox model was about 55 miles, the GFS is about 85 miles, and that could make a significant difference as to how high your winds are going to be and things like that. So let's go through this again, and I'm going to segue this into that discussion of the cone of uncertainty here as well. So if it makes its closest approach here early Wednesday, by the way, this model's a little faster. I think the Euro's been running a little slower. So you not only have error on how strong the storm is going to be, there's going to be some give and take there. There's also going to be some error on left or right. You know, does the storm come a little closer to Houston or a little bit farther away from Houston and Galveston? There's also error as to the timing. You know, is the worst of the weather hitting Tuesday night or midday Wednesday or late in the day Wednesday? Right now it looks like midday Wednesday. Anywhere from like late Tuesday night through midday Wednesday is probably when we're going to see some of the worst of the weather. I want to share this with you because I want to talk about the difference between cone of uncertainty and area of influence. The cone of uncertainty is only giving you like an envelope of where the center of circulation is expected to be. Now, the center of circulation falls into the cone of uncertainty about 2/3 of the time. So 1/3 of the time it ends up outside of the cone, but most of the time it ends up within the cone, the center of circulation. Now, this cone would be the same size if we were talking about a tiny tropical storm or a gigantic Category 5 hurricane. The cone would be the same. So let me state that again because it's a little bit weird to think about. The cone is only showing you the range of possibilities of where the center of a storm would be. You could have a tiny storm where, let's say, the extent of the tropical storm force or hurricane force winds is yay big, or you could have a gigantic, you know, Hurricane Katrina, or even a gigantic like Hurricane Ike, Category 2, where the area of influence is huge, takes up the whole map. So that's why looking at the cone, we talked about this in last year's hurricane special when I got a chance to interview Brian Norcross from the, he's formerly of Miami, fame in Miami from Channel 10 down there and Channel 6. And anyway, he's been one of my idols for a long time, but he's the hurricane specialist now with Fox Weather. And one of the things that he focused in on is that when a storm is far away, you want to focus on the cone. When the storm is close to making landfall, you want to ignore the cone. So what do we mean by that? Well, let me adjust this here. Hold on just a second. All right, so here we go. So I want you to notice here that when you're close to the center of circulation, the cone is very small, very skinny. And that makes perfect sense because you kind of know where it's moving in the short term. Therefore, the cone is going to be very thin. The farther out you go, the cone gets larger and larger. So we can see here that once you go out to the 5-day forecast, the cone is huge. The cone stretches all the way across Missouri and all the way back over to central Kentucky. So it's hundreds of miles across when you're on day 5. but might only be 10 or 20 or 30 miles across when you're on the 12-hour forecast. So what that means for us here is that when you're like 2 days away from landfall, like we are, you can focus on the cone, because the cone is going to include areas that are likely to be near the highest winds and likely to suffer the greatest impacts. Once you get closer to landfall, though, the cone gets small, the storm might get bigger. So right now, the area of influence of the storm might be roughly the size of the cone. Whoops, I lost my light here. I lost my light. Might be roughly the size of the cone. But by the time you get close to landfall, like tomorrow, if we're 1 day away from landfall, focusing on the cone is a fool's errand, because the extent of the hurricane or tropical storm force winds, the extent of the rain, the extent of the storm surge or coastal flooding might occur hundreds of miles outside of that cone. So we've learned a lot of lessons about the cone over the years, and the fact that hurricanes are big systems. Hurricanes, every hurricane is different. Every tropical storm is different. They vary, how fast are they moving? How wide is the wind field? What kind of angle do they hit the coastline? How long have they been over water? Are they weakening upon landfall or strengthening upon landfall? I mean, there's so many variables with these storms that you can't just, let's think of Hurricane Beryl. That was a Category 1. We've been through lots of Category 1s, and rarely do we have one that had as big of an impact as Beryl did, with knocking down trees and cutting off power. So the influence area is very often going to be much larger than the cone of uncertainty implies. All right, back to a couple of things here that I want to share with you. All right, I showed you the GFS model and the Fox model. Let's look at this, which is a wind probability map. So this one divides up into 4 categories. Your threat for getting in on tropical storm force winds. Tropical storm force is 40 miles per hour or higher. Technically, you'll see it 39 miles per hour or higher, but the truth is they don't measure winds. They always it would never be 39, it would always be 40, I guess is what I'm trying to say. You'll always see 35, 40, 45. They're not going to say this has 39 mile per hour winds or 38 mile per hour winds. It just doesn't work that way. So in practice, once the winds get to 40, that's considered a tropical storm. Once they get to 75, that's a hurricane. We're talking about maximum sustained winds. In this case, this map shows us the probability of experiencing tropical storm force winds at these given locations. So in this case, this line here is the center forecast line from the National Hurricane Center, and it's showing the red area having a high risk for 40 to 75 mile per hour winds. And as far as our area here, notice Chambers County, Galveston County, Brazoria County, Matagorda County is in this area here with a medium risk. And then the Houston area and most of the surrounding suburbs are under that low risk. So let's say the low risk might be something like 20% or less. Not nothing. Whoops, sorry. It's not nothing, but it's not a huge risk. But we do want to be mindful that later today, tonight, the forecast could certainly change. And as I showed you earlier, the Fox model showed the circulation 55 miles away. The GFS showed the circulation 85 miles away. So even if the forecast shifts 50 miles, which isn't that much, to the west, now all of a sudden we're in for it, right? Now all of a sudden we're in for some pretty nasty weather. So let me go ahead and I'm gonna move the camera over to the big wall so I can show you a few more things. So let me just maybe demonstrate this again. sort of driving home this point of cone of influence, or cone of influence versus cone of uncertainty, or area of influence versus cone of uncertainty. And here are some examples in this case. So this is the cone of uncertainty from the National Hurricane Center, and it shows just the outer edge of the cone right around the Bolivar Peninsula, and then the other outer edge of the cone here around, well, just near Houma, Louisiana, near Thibodaux, Louisiana, and back over to New Orleans. But check this out. Well outside of the storm surge, for example, there are flood warnings that are up for deep South Texas. They're looking for heavy rain, some flooding, and even some storm surge, because remember, there's going to be huge waves from the system crashing up against their coastline. So they are well outside of the cone of uncertainty, but the area of influence is reaching probably at least 100 miles, if not more, a couple of 100 miles, to the west of where the cone of uncertainty ends. As far as our local area, we have a threat for heavy rain and coastal flooding from Matagorda Bay up to Galveston Bay. None of those areas are in the cone of uncertainty because the cone is just tracking the center, as I mentioned a moment ago. So if the center is out here and you have this area of influence that, again, is hundreds of miles stretching away from the center and therefore the cone. Over here, another example. So outside of the cone of uncertainty, the Mississippi Delta region here of Louisiana, and also here in Mississippi. So this whole area, even over to the Florida Panhandle, way outside the cone of uncertainty, heavy rain possible along with coastal flooding. And then as the system moves inland, there'll be a flash flood risk for areas that are far inland, again, far outside of that cone of uncertainty. And so this is something that, we kind of deal with every single time one of these systems passes through, is that each one is different. They have different sizes. They hit the coastline with different angles and so forth. And so you never really 100% can predict ahead of time who's going to be impacted the most. I'm going to hit a button over here on my computer because I want to make sure that I get to the next graphic here for you. And here we go. So the rainfall totals could be pretty rough. So we are looking, like I said, the cone of uncertainty ends there, right? But heavy rain outside of the cone. The cone of uncertainty, I think, ended right around there. Heavy rain over here. So a pretty widespread area here of maybe 4 to 6 to 7 inches of rain is being predicted right now by the GFS computer model. May turn out to be some isolated locations of maybe a lot more than that in some spots. Let me show you this. This is the Euro model, which, by the way, kind of has the best track record over the last several years. It's earned the best reputation. The European model is run twice a day. The GFS is run 4 times a day. The European model is has more data points and what we call a higher resolution, as far as how many kilometers the little squares are, is like pixels. Think about it like Ultra HD TV versus HD TV, or 8K TV versus 4K TV. Well, the Euro model they've invested earlier in more powerful computers, and therefore they run a more detailed model. Doesn't mean it's always right, but it has gotten a better reputation. And I'll tell you that as of the latest Euro computer model run, they're showing the center of circulation over here actually farther away from Galveston than either the GFS or than the Fox model. Remember, that Fox model showed it the closest to us, and the Euro shows it. I hope that, for our sake, I hope this is right. But either way, it's looking like bad news for Louisiana as this thing moves in. Could potentially pass right over Lafayette, Louisiana, which would actually cause a storm surge here in Vermilion Bay, and also a storm surge potentially over here along those marshy areas of the southeast Louisiana coastline. Notice, though, here, it actually shows some clearing conditions in the Houston area coming up on Thursday. Might even turn out to be a sunny day, potentially. And then the system moves off toward the north, and we're going to transition to a sunny, hot pattern after the hurricane passes. I did want to point out to you the steering kind of mechanisms here of why it looks like it'll probably not make a direct hit on us. And it has to do with a little dip in the jet stream out here. And if you look at those little white lines, the stream lines indicate mid-level steering currents. This is about 18,000 feet above the ground. And it's showing them flowing like this right now. and they should kind of stay that way for the next 24 hours. So whatever forms down there, whether it's a tropical storm or a hurricane, as it moves to the north, it should start to feel the influence of that steering current and start to curve. Now, again, it's not a guarantee, but those are the factors that are in play right now. Good news is that we're going to experience great weather today. Get out there and enjoy this afternoon, because tomorrow might get a little bit iffy in some locations, depending on how close the storm gets to us. We also have another pretty decent night tonight as far as temperatures getting down to about 71. A lot of the state down in the 50s again for this morning. So enjoy today, and then tonight should still be relatively quiet. Watch out for the chance for a few storms along the coastline, even first thing tomorrow morning. We could be waking up to some pretty nasty conditions down there. You know how it gets on Galveston. I mean, it gets really windy in a hurry, even if the storms are really far away. And then some of that rain starts to move in through the day on Tuesday, with a chance for some heavy downpours from Houston southward into Fort Bend and Brazoria County and down to the coastline in particular, as we watch this system start to get ramped up. By the way, this model here is called our GRAPH model. It's a model by IBM. GRAPH stands for Global Rapid Update Atmospheric Forecast Model. Meteorologists love acronyms. So anyway, this is where it's showing the center of circulation, which again would kind of favor it in doing one of these, heading toward Louisiana. Finally, let me just leave you with this. Good news in your 7-day forecast for today and for the late part of the week. But we got a little bump in the road there, obviously. Please stay tuned for updates, for any indications that maybe the storm does something unexpected and starts to either grow in size or takes a little jog closer to Texas. But the way things are looking right now, we need to be mindful from late Tuesday through the day on Wednesday for the chance for some heavy rain and coastal flooding, with much lower impacts the farther inland you go, west of Katy, north of Tomball, in those spots. Thanks for joining me for Mondays with Mike. Squeeze this in between our shows, between the after show and forecasting with friends and the news at noon. I got so much going on. So anyway, thanks for joining me today.